railroads play an important role in moving our goods and products throughout our nation. In the water industry, we rely on pumps to move water. There are many types of pumps that perform a variety of functions. This production is going to focus on the chemical feed pumps. Properly calibrated chemical feed pumps help us to deliver accurate dosages of chemicals to provide safe, clean water. Jar testing is often used to indicate the proper dose for treating your water. Once you have determined the proper dose, you will need some way of getting the chemical into the water. Usually, this requires some type of chemical feed pump. There are a variety of pumps and pump types to choose from. Choosing the right pump for the intended purpose is critical to the proper operation of the water treatment plant. Some of the considerations in choosing a chemical feed pump are the type of pump to be used, the amount of chemical to be pumped, the normal operating pressures of the application, and how the pump will be utilized. Choosing a pump type is largely a matter of preference. It may be helpful to check with other operators to get an idea of how reliable different types of pumps have been, how much care and maintenance different pumps require, and how easy a pump is to adjust and maintain. Another consideration in purchasing a pump is the parts inventory you should carry. Limiting the type, manufacturer, and model of pump where possible allows you to minimize the parts inventory required to ensure continuous operation of the chemical feed pumps. Two popular pump types are peristaltic pumps and diaphragm pumps. Peristaltic pumps use a pliable tube and a rotating cam. As the cam presses against the flexible tube, it squeezes out the chemical in the tube. The feed rate can be adjusted by changing the speed of the rotating cam. Some pumps can be adjusted by setting an on-off timer for intermittent feeds. The pump will come on and feed for a preset time, then be off for a designated period of time. This application is suitable for situations where the chemical is not applied to rapidly flowing water. For example, having off cycles where there is no chemical being added for a length of time while the raw water is still flowing would not be appropriate for a disinfection application. The diaphragm pumps use a flexible diaphragm to inject the liquid. The diaphragm simultaneously draws the chemical into the chamber and pushes it out the top into the feed line with every cycle. Diaphragm pumps frequently have two adjustment options, the speed and the stroke. The speed refers to the frequency of the strokes, or how rapidly the pump will pulse. The stroke refers to the length the plunger will travel in one stroke. The longer the stroke, the more chemical is pumped. Another type of pump uses a motor-driven pulley system. Stroke adjustments are made by turning the crank in either direction, while speed adjustments are made by aligning the different sized pulleys on the pump and the motor. Pump size in terms of capacity is a critical issue. There is no such thing as one size fits all when it comes to chemical feed pumps. Purchasing a pump that is not capable of delivering an adequate amount of chemical may seem foolish to some operators, but buying a pump that is too large may ultimately have the same effect: inadequately treated water. Some chemicals like polymers and polyphosphates may be delivered in very small dosages, so they often require pumps that can deliver small quantities accurately and consistently. The daily output of these pumps may be measured in fractions of gallons per day. Pump manufacturers have recommended operating ranges for their pumps. For those pumps that have speed and stroke adjustments, setting the stroke too low will not provide consistent water treatment and may actually do long-term damage to the pump. If the speed is set too slow, The problem may be the same as with peristaltic pumps. Chemical feed pulses may be so far apart that significant quantities of water may pass through untreated between pulses. Some pumps are set to pump a fixed amount whenever they are in operation. Others can be set to respond to varying input signals to yield differing amounts in response to changing conditions. For example, pumps can be flow-paced, so they vary delivery rates with changing flow rates. A sensing unit picks up the rate of flow and sends a corresponding signal to the chem feed pump, delivering more chemical for higher flows and less for lower flow conditions. Some pumps can be programmed to respond to signals set in a prescribed range. Some pumps run off a 4 to 20 milliamp signal, while others respond to a DC current of 1 to 5 volts. The operators should be careful to match the signals from the sensors to the pumps. Other pieces of equipment that are essential to the operation of chemical feed pumps are check valves, foot valves, and four-way valves. Check valves prevent the backflow of water out of the supply side of the pump so that the pump does not lose prime between operations. They are frequently nothing more than a porcelain ball that rests against a plastic housing like this. This prevents leakage from the feed line, which would result in a loss of prime to the pump if it occurred. One of the symptoms of lost prime is a louder than usual sound made by the diaphragm during operation. Once the pump loses prime, it will need to be primed manually. This can be accomplished by relieving the pressure on the outlet of the pump, making it easier for the pump to draw the chemical into the feed line. Once the pump has been primed, it should continue to operate automatically. A pump that loses prime frequently may have a crack in the line or some other problem that allows the fluid to drain. Check valves are frequently accompanied by a foot valve, similar to the type shown here. The screen is used to protect the seat and ball so that material does not become lodged on the device, preventing the seal. The screens should be checked and cleaned periodically. There are also check valves on the diaphragm of the pump. Assuming that you have purchased the right pump for the job does not mean that you can just plug it in and watch it work. Some pump manufacturers suggest that the output of a pump can be estimated by multiplying the rated capacity of the pump by the speed setting and the stroke setting. For example, if a pump is rated at 50 gallons per day maximum, and the speed is set at 70, and the stroke is set at 75, the pump should be delivering about 27 gallons a day. To get this estimate, the maximum output of 50 gallons per day is multiplied by the speed setting of 0.70, yielding 35 gallons per day. Then by the stroke setting of 75, which gives about 27 gallons per day. Regardless of whether the manufacturer suggests this method or not, the best way to determine the efficiency of a pump is to do a pump calibration. A pump calibration should be done on pumps when they are new, as well as periodically after they are in service to verify their delivery rates. Sometimes pump delivery will vary as the parts age and weaken. To do a pump calibration, the following equipment is necessary: a calibration tube of proper size, a timer or stopwatch, tubing to connect the pump to the chemical supply it will be pumping, and a beaker to receive the chemical if a calibration tube is not plumbed into the feed line. The calibration tube can be installed in line on the chemical feed line using two valves and unions. This is the optimal arrangement for doing pump calibrations because it uses the chemical to be pumped and operates under the actual pressures and conditions of normal usage. To do a calibration, fill the tube with the liquid to be pumped. This is easily done if the tube is connected in line with the chemical feed barrel. The operator needs to close the valve to the pump and open the valve from the chemical feed barrel and to the calibration tube. Once the tube is filled, the valve from the chemical feed tank is closed, and the valve from the tube to the pump is opened. Using the actual liquid to be pumped when calibrating is preferable to using water, because different liquids may have different viscosities, which means they may have different delivery characteristics. Prime the pump by turning it on and operating until the chemical is being ejected from the discharge side. Next, set the pump at the lowest setting to be used in the calibration. If the pump has speed and stroke settings, set the stroke to 30 and the speed to 20. Caution should be exercised when adjusting the pump to follow the manufacturer's recommendations for adjusting. Some manufacturers state that adjustments are to be made only when the chemical pump is operating. Otherwise, the pump may be damaged. Mark the level of the chemical in the calibration tube and start pumping. Time the pump for 2 to 3 minutes. The longer time at the lower stroke settings gives the pump time to become consistent and compensates for any minor glitches the pump may experience. At the end of the designated time, mark the level in the tube and subtract the difference from the starting level. Divide the difference by the number of minutes the test was run for to get the milliliters per minute flow rate. Next, set the pump speed to 40 while keeping the stroke at 30%. Refill the calibration tube and time for 2 minutes again. The process should be repeated for 60, 80, and 100% speeds. The time can be reduced to 1 minute for the higher speed settings. The results should be recorded on a table and graphed like the example shown here. By drawing a line through the points, the operator can illustrate the delivery characteristics of the pump. The process should be repeated for stroke settings of 45, 60, 75, and 90. The operator then can compare the various results and choose the most linear curve for the normal pump operation. Operators should be able to predict reasonably well what the delivery will be at settings within the ranges established by the graph. This information should be kept near the pump in a waterproof container so it can be easily referenced when adjustments are required. Coupling this information with historical records from past events will enable the operator to make accurate adjustments of chemical feeds in response to changing water quality characteristics. There are a variety of chemical feed pumps and pump types to choose from. The operator should be careful to select the pump that will deliver the chemical accurately and consistently. Sizing the pump correctly is critical to the proper operation of a water treatment plant. All pumps should be calibrated when they are first put online and after any maintenance is done or parts have been replaced. Choosing similar pumps in terms of manufacturer and size when possible will lower the parts inventory required for uninterrupted operation. An ongoing operation and maintenance program is essential for chemical feed pumps as well as the other types of pumps used in water treatment. Pump calibrations are another vital tool for the water treatment plant operators, producing an effluent that meets all permit requirements on a consistent basis, protecting our precious waterways for current and future generations to come.